In this video, we're going to look at modeling with trig functions, or basically word problems. So we want to be able to write an equation to model a periodic relationship, and then we want to be able to solve problems involving that, whether we're plugging in values for x or solving the equation. All right, so in general, when you're looking at a word problem situation, I would suggest that you maybe sketch a graph of the function. Typically, when you do that, time's going to go on the x-axis, and then whatever other value you're dealing with is going to go on the y-axis. It could be height, it could be depth of water, it could be population, whatever. We want to be able to figure out the amplitude, the period, the vertical shift, and the phase shift of that graph once we kind of sketch the graph. So you can plot some points and kind of go from there. You want to look for some key points, which would be maximums and minimums and what time they occur. Your period and your phase shift are always going to be time because they're going to be x values. So that should kind of help you as you're going through the problem as well. All right, so remembering your general equation, A, sine or cosine, B, remember B is your value that you're going to calculate from your period, and then you've got your phase shift inside your parentheses, and then D is your vertical shift. So remember, we want to find the amplitude, and amplitude is 1/2 maximum minus minimum. Once you determine your period from your graph or your information, you're going to calculate your B value, 2 pi divided by period. Remember, you could use 360 here, but usually we're going to work in radians. Phase shift is going to be a time value, and if you work in cosine, then that phase shift is going to be the time that you reach your maximum. So my advice would be to try to write most of your equations using cosine because it's usually easier. And then your phase shift is the time that your maximum occurs. So D is your vertical shift, and that is 1/2 maximum plus minimum. This particular question is talking about the tide. So high tide occurred at 9 a.m. At that time, the water was 2.7 meters deep. Low tide occurred at 4 p.m. At that time, the water was only 2.1 meters deep. Assume that the depth of the water is a sinusoidal function of time. So you might see this word sinusoidal. You might see the word sine wave. Either of those words means that you could do a sine or a cosine graph. So just because you see sinusoidal or sine wave does not imply that you have to use sine. So at what time on the 4th of July did the first low tide occur? And then what was the approximate depth of the water at 6 a.m. and 3 p.m. on that day? So the first thing I want to do is come up with an equation to model this situation. The thing I'm going to do is sketch a graph. Our high tide occurred at 9 a.m. and was 2.7 meters deep. So at 9 a.m. we hit our maximum, which is 2.7. And then at 4 p.m. we hit low tide, which was 2.1. So this would be 4, and then that's going to be my minimum at 2.1. So my curve is coming down to the minimum, and then it would go back up, and then obviously here it's going to come down, it's going to hit this minimum again and kind of go back up. So we know our maximum is 2.7 and it occurred at 9 a.m. And then we know our minimum is 2.1 and it occurred at 4 p.m. So now when we're dealing with time like this with the p.m., we want to change that into 4 plus 12, and I'm going to make that 16. So p.m., remember, means afternoon, so after the 12 hours. So just change that into kind of military time. So I'm going to make this 16 here. So from our maximum minimum, we can calculate our amplitude, which is 1/2 maximum minus minimum, which is going to give us 0.3. We can also calculate our vertical shift, which is 1/2 maximum plus minimum, and we're going to get a 2.4. Next, we can talk about the period. So the period is time it takes to go from maximum to maximum or minimum to minimum. So to get from the maximum to the minimum is going to be 7 hours. So then to get from the minimum back to the next maximum is going to be another 7 hours. So our period is going to be 14 hours, which gives us a B value of 2 pi over 14, which reduces to pi over 7. Then the next thing we want to think about is our phase shift. Remember, if we do our phase shift in terms of cosine, then we want to look for where a maximum occurs. So here's my maximum, and it's occurring at an x value of 9. So my phase shift is going to be 9. Then I have everything I need to write my equation. So we're going to do y equals 0.3 because that's my amplitude. And then we chose to use cosine. And then our b value, so pi over 7. And then x minus 9. And then our vertical shift of 2.4. Okay, so now we want to kind of just look at the questions that were asked. So the first question asked us when the first low tide occurred. So that's over here somewhere. So remember, the time from high tide to low tide is 7. So if we want to go backwards, we're going to subtract 7, which is going to take us to 2. So we had low tide at 2 a.m. So to answer B, we're going to use our calculator and graph this equation that we came up with. So if we enter that equation into our calculator, and then in our window, I'm going to change this. I'm going to change my x values, x min -2, and then I did x max of 24 because we're looking at one day here, so 24 hours. So I'm just going to kind of change that in terms of this particular problem. So then we get this graph. I'm just going to check so far that our answers are correct. So I'm going to do second trace value, and I'm just going to check that at 9 a.m. we're at our maximum, which we are, and at 4 p.m., which is 16 hours after midnight, we're at our minimum of 2.1. And then we said that first low tide was at 2 a.m., so I'm just going to check that. So 2 a.m., we're at 2.1 again. So far, we're looking like we're in good shape. So then what's the depth of the water at 6 a.m.? So 6 a.m. is 6 hours after midnight, so we could just put in x equals 6. So putting in x equals 6, we can get that the water is about 2.5 meters deep. And then the other part of the question asks us what was going to happen at 3 p.m. So remember, we have to change that sort of into military time. So 12 plus 3 is going to be 15. So if we put in x equals 15, then we can get our other answer. So then at 6 a.m., we get the water is about 2.5 meters. And at 3 p.m., that would be x equals 15. The water is about 2.1 meters deep. All right, in the second question, there's a lot of words, so don't get intimidated when there's a lot of words because usually they're giving you more information then. So a weight is suspended from a spring and it's going to remain at equilibrium until it is pulled. So assuming no friction and air resistance, the weight will be pulled a small distance and then it will oscillate infinitely. So it's going to go up and down forever. So I'm going to just start plotting these points here. At time equals 0, the weight's pulled down 3 centimeters. So at x equals 0, my y value is going to be -3. After 1 second, it's back at equilibrium, so that would be a y value of 0. So at 1 second, I'm here back at the axis. At 2 seconds, it's 3 centimeters above the equilibrium point. At 3 seconds, we're back at equilibrium. And at 4 seconds, we are 3 centimeters below again. So now we're back to here. So my motion looks something like this, and it would continue. So find an equation to model the height as a function of time. So here my max and my min are 3 and -3 respectively, which is going to give me an amplitude of 3 and a vertical shift of 0. Remember, period's the time it takes to get from maximum to maximum or minimum to minimum. So I started at my minimum and was back to my minimum at 4 seconds. So my period is 4, which is going to give me a b value of 2 pi over 4, or we can reduce that to pi over 2. This problem is actually equally easy to do as either sine or cosine, but let's just stick with our cosine method to just kind of keep that. So for cosine, I'm looking for my maximum, and that maximum occurs at 2 seconds. So my phase shift for cosine is going to be 2. So my equation then is going to be y equals my amplitude, which is 3. We chose to do cosine. My b value, which is pi over 2. X minus my phase shift, which is 2. If I had a vertical shift, we would put it here, so we could do the +0, or you can just leave it off. It doesn't matter. Then it asks us to give the next 2 times that the weight's going to hit its maximum point. So remember, the time to get to maximum is the period. So if I started at 2 to get back to another maximum, I'm going to add the period, which is 4. So 2 plus 4 is going to give me 6, so I'm going to get another maximum at 6 seconds. I'm going to add the period again, so 4 more seconds later would be also at 10 seconds. All right, in this third example, we have Darlene, and she's in the seat labeled D. When the Ferris wheel starts, that's time equals 0. It takes 10 seconds for her to get to the top, and that would be the maximum, and then she has 45 feet above the ground. So at this point, we know that the maximum is 45 feet. And we know that that occurs at 10 seconds. The wheel turns at a uniform speed of 2 revolutions per minute. So this information right here is helping us to find our period. The wheel turns with a uniform speed of 2 revolutions per minute. So 2 revolutions in 1 minute, or 60 seconds. So 1 revolution in 30 seconds. So my period is 30 seconds. And then my b value is going to be 2 pi over 30, or pi over 15. So we have our maximum. We actually have the time that happens where our maximum happens. So this is actually my phase shift. I've got my period, which gave me my B value. So really what I need to find now is my minimum so that I can get my amplitude and my vertical shift. So I know my maximum is 45 feet. And I know the distance from the center to the ground is 25 feet. So that tells me if I do 45 minus 20, the radius of this Ferris wheel is 20. So then that means this would be 20. So the Ferris wheel is actually 40. And since the distance from the top to the bottom, from the top to the ground is 45, then that tells me that this leaves me with 5 feet down here. So my minimum is 5 feet. So then that would allow me to calculate my amplitude and my vertical shift. So my amplitude's half of the max minus the min, which is going to give me 20. My vertical shift is 1/2 maximum plus minimum, which is going to give me 25. So now this question just asked me to find an equation to model the height as a function of time. So my equation here is going to be y equals my amplitude, which is 20. We're using cosine again because we did the phase shift at the maximum. Our b value is pi over 15. So then we've got x minus our phase shift, which is 10, and then plus our vertical shift, which is 25. So you can use your calculator to kind of double check yourself. So I'm going to put this equation into the calculator. I'm going to go to my window. You're going to have to adjust your window a little bit here. So remember, we're talking about working in terms of seconds here, and our period is 30 seconds. So I'm going to go like maybe from -2 to 60. So we'll just look at 2 rotations there. And then here we want to think about my y min and my y max. So my y min was 5, so I'm just going to leave that at -4. My y max was 45, so I'm just going to make that 50. And I can take a look at my graph. Then what I could do is check the points that I know. So I know that at time 10 seconds, we should be at the maximum. So I'm just going to check that. So second trace maxima or value at x equals 10, and we are at the maximum. So just a nice place to kind of double check yourself. All right, and then this question, we're talking about a satellite deployed from the space shuttle, and it's going to go alternatively north and south of the equator. Its distance over time can be approximated by a sine wave. Remember that this does not imply that we have to use sine. We can still use sine or cosine. Suppose that the satellite is y kilometers north of the equator at time equals x minutes. So this is just telling us to write our equation using y representing the satellite's position and x representing time, and that we should use minutes for time. So when the satellite is south of the equator, it's going to be negative. So we're going to kind of think of the equator as 0. So it reaches 45 kilometers, its farthest point north, so that's going to indicate maximum at 15 minutes after launch. So then this is also telling me my phase shift if we use cosine. So again, if I just want to kind of think about a graph here. So 15 minutes after launch, we're hitting our maximum, which is 4,500 kilometers north. Half an orbit later, it hits 45 kilometers south, its farthest point south, so now we know that that's our minimum. So negative 4,500 is going to be my minimum. So my graph's going to look something like this. One complete orbit takes 2 hours. Remember that they told us to work in minutes here, x minutes, so I'm going to change this. Instead of 2 hours, I'm going to change this to 120 minutes. So this is my period because that's the time it takes to do one complete orbit. So I know my period is 120 minutes. So then my b value is going to be 2 pi over 120 or pi over 60. My max and min are 4,500 and negative 4,500 respectively. So that's going to give me an amplitude of 4,500 and a vertical shift of 0. And then remember we said that this 15 minutes is the time that my maximum occurs, so my phase shift is 15 minutes. So always make sure your phase shift and your period are in the same unit. So now I can write this equation. So y equals my amplitude, which is 4,500, cosine pi over 60, x minus 15. I have no vertical shift, so again, if you need to, write the +0 or you can just leave it off. So again, using my calculator to check, I'm going to put my equation in. I'm going to go back to my window. You really have to think about your window here. So remember my period is 120, so I'm just going to go a little bit past that. I'm going to go like maybe 200. And then your x-min and your x-max were negative, or I'm sorry, your y-min and your y-max were negative 4,500 and 4,500. So I'm going to go just 5,000. So negative 5,000 to positive 5,000, just so I have a little bit of room to work with. So then that's my graph. And then really the only point that I can check right now is 15. So at 15, I should be at my maximum. So I'm just going to try that. So at x equals 15, I'm at my maximum point of 4,500. So I can feel fairly confident about my answer here.